Good day. Our project title is Decoding Music Law with Natural Language Processing. We're going to take you through the problem statement, objective, methodology, results, challenges, as well as future work. The Copyright Amendment Bill in South Africa is being reformed because the existing copyright law is outdated and it doesn't meet modern needs. As a result, there has been a significant number of public submissions to Parliament from artists, industry organizations, and civil society. The amount of unstructured data and the complex legal language used makes it difficult for people who are not experts, especially music creators, to understand, navigate, or act upon this information, although it's publicly available. As a result, important information about the issues, concerns, and the entities influencing the reform discussion is mainly unavailable. We are leveraging natural language processing, aiming to bridge the gap by automatically uncovering the entities that are influencing the reform discussion, thus discovering the key actors. The goal is to build a tool that identifies the issues and key actors raised during the legislative process and make this information accessible through the tool to empower legal educators, music creators, and policymakers with clear, actionable insights. This ultimately contributes to the improvement of access to justice, empowerment of music industry participants, and strengthens the international positioning of South African music law. For our methodology, we perform text extraction and pre-processing. We ingest raw data in the form of Word documents, PowerPoint documents, PDFs, and text files. Data cleaning and normalization is performed, and we make use of named entity recognition to identify the key actors. Our data was not labeled. We had a taxonomy with various categories and definitions, which we made use of to label our documents. We made use of hybrid labeling strategy, making use of three approaches, ultimately creating a dictionary by mapping taxonomy file categories to definitions. We made use of direct match, which uses regex for looking up category keywords in the text, semantic matching, which uses a sentence transformer to generate fixed size vector embeddings for each category and definition pair. And we also made use of definition matching, which searches for legal definition phrases. For our dataset construction, we filtered out documents that failed to match any category, and we split the data into training, validation, and testing. For vectorization and classical models, we made use of a TF-IDF vectorizer to build a 2000 feature for vocabulary training. We trained three models: random forest, logistic regression, and LegalBERT. Random forest had 100 trees, and logistic regression classifier was trained on TF-IDF representation with balanced weights to mitigate imbalance. We fine-tuned LegalBERT, and we also performed sentiment analysis. We evaluated our model using various metrics, and we also visualized. We saved our final outputs into CSV files with document level predictions, actors, issue tone, and matched statute definitions.
Thanks, Juliet. So now I'm just gonna quickly take you through the training data distribution. So as you can see on our far left, on our various categories that we have, there's only three categories that were not represented, and some of the categories that were they had a lot of data. So with our three models, the logistic, regression, random forest, and the LegalBERT, From the confusion matrix, we can see that the logistic regression is performing way better than the other ones because it's correctly classifying the documents since it has less false positives as compared to the other models. So the metrics that we used to evaluate our three models is the accuracy, the precision, the recall, and the F1 score. And across the board, the logistic regression is the one that performed better as compared to the others. So we also performed sentiment analysis, and here we are showing the distribution across the different issues. So as to close and to summarize what the insights that we've collected. So we have a CSV file that outputs the key actors, key issue, sentiments, the predicted category, and the specific issue that is being addressed per document. So for instance, on the copy of the joint academic opinion presentation, we can see that the various actors that are involved in the reform of the bills that we previously talked about is the development and innovation, or the research, development and innovation, and there's the presidential commission. So those are one of the key actors, and the predicted category is fair use and fair dealings, which has a negative sentiment. And the addressed issue was the legal doctrines allowing the limited use of copyrighted material without permission in specific cases. So it having a negative sentiment, it shows that one of these categories, it's supposed to be prioritized because it's one of the most prevalent faults that were detected in these submissions. And then a positive sentiment might show that it might be a suggestion or an opinion on how to strengthen, for example, the moral rights issue that was being experienced. So we also developed an interactive tool where one can upload a document and also see what predicted category or what specific section of the copyrights bill and protection amendment bill is being addressed. In this case, we can see that the document that we've uploaded, the SAGA submission, the PDF, it was classified as a copyright ownership, and the user can also preview the text and see what's also contained in the document. So the challenges that we had is that the data that was provided, it was raw files, which were 149, and there was no labeled data set or curated data set for us to use. So we had to come up with certain techniques that were defined in the pipeline on how to label and match so that we can achieve our categorization of the local document. So on the previous two slides, we saw that there was an imbalance in our data set, and we managed to address some of those issues within our pipeline. So the other limitation is that we couldn't properly perform the fine-tuning since we had a very low number of documents, and fine-tuning is also computationally expensive, especially when you don't have a GPU. And another limitation that we currently have is that the interactive tool can only process one document at a time. So for future work, it would be nice to have batch processing of documents for the Streamlit interface, and also have a curated labeled dataset for the Copyright Amendment Bill and Performance Protection Act. And that is the conclusion of our presentation. Thank you for your time.